Alright, we have a practice problem here. Is f of x equals 3x squared minus 5x plus 8. We're going to find f prime of x, which is the derivative, and we're going to eventually write the tangent line at x equals 1. So the first thing we got to do is find this derivative. So we've got f of x equals 3x squared minus 5x plus 8. And then we also need f of x plus h, which is a little bit longer than it first appears. So that'll be 3 times x plus h squared minus 5 times x plus h plus 8. So whenever we plug something in for x, we plug it in every location. So since it's a quadratic with 2 different x inputs, we got to put it in both places. And now we got to multiply all that out. So we'll have 3 times, and if we do x plus h squared, that'll be x squared plus 2xh plus h squared. We can distribute this negative 5, so minus 5x minus 5h plus 8. So now we still got to keep cleaning up. I got to push that 3 through. 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 8. And I don't think anything there combines. So that is a little bit of work just getting things ready to use the limit formula, which the limit formula for derivative f prime of x, remember, was limit as h approaches 0 of f of x plus h minus f of x all over h. So let's plug in what we just found. We've got the limit as h approaches 0 of, f of x plus h. We did a lot of work getting that together. So it's 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 8. And then we've got minus f of x, which is minus the quantity of 3x squared minus 5x plus 8. Okay? For some reason it doesn't like me writing toward the edge here, so there's a plus 8. And all of that is over a wavy line of h. So let's kind of look at what we've got here. Up top we've got some terms. We've got 3x squared from the first part, and we've got a minus 3x squared from the second part, which will knock each other out. We've got a minus 5x from the first part, and we've got a minus 5x from the second part, which will knock each other out. And then we've got a plus 8 from the x plus h part, and we've got a minus 8 when we distribute from the f of x part. So we've got some things that will go. Okay, and where does that leave us? That leaves us with the derivative being equal to the limit as h approaches 0 of 6xh plus 3h squared minus 5h all over h. And look at what we have here. We have a, we're trying to get rid of that h on the bottom because we don't want it to be 0, but there's a term, there's an h in every term up top. So we can pull that h out and cancel it. I'm not sure how I ended up on that color. So we still got the limit as h approaches 0, but if we factor in h out of the top, it'll be h times the quantity of 6x plus 3h minus 5 all over h, and we can cancel that h out of the top and bottom. To save a little bit, well, we don't have to save space. We still have this thing with the limit, so f prime of x equals the limit h approaches 0. 6x plus 3h minus 5. Oh, there's no denominator there, so I don't have to write like that. Let me erase this. Okay. 6x plus 3h minus 5. And at this point, it is okay to let h be 0. And if I do, it knocks out that middle term. So the derivative here that we get after all this cleanup is f prime of x equals 6x minus 5. So that is the derivative. Okay. Now, after all that work, hopefully we did a good job, but now we want to find the tangent line, so let's work on that. Okay. So with the tangent line here, we know we need an xy and we need an m. So where do we get these? We're given the x of 1, so we'll plug 1 into our function, which was 3x squared minus 5x plus 8. So that will give me 11 minus 5 looks like 6. So I have the point 1, 6 if I'm not mistaken. Might be worth reinvestigating. Looks good. And I'm going to plug the 1 into the derivative, which was 6x minus 5, and that gives me a 1. So m is 1. So I'm using this point of 1, 6 and this slope of 1 to write the tangent line. So let's see. Y minus y naught equals m times x minus x naught. Plug these in. Y minus 6 equals 1 times x minus 1. That 1 is kind of useless, so we'll just go ahead and pull the 6 over. Y equals x. So we'll have minus 1 plus 6, so plus 5. So let's make sure that makes sense. It seems to. So the tangent line is y equals x plus 5. The derivative is 6x minus 5. I'm going to pause this and pull up the graph just so you can see it, and we'll go from there. Okay, so we had the function 3x squared minus 5x plus 8, and we were going to graph it. So this is what it looks like. It's a parabola. And then we decided to look at when x is 1, and when we plugged in x is 1, we got y is 6, so we have that point down here. And then we calculated the tangent line to be y equals x plus 5. So there's the y-intercept of 5 and the slope of 1 going up to here, and it's just touching that curve right there on that point. Okay. So we can validate it's a tangent line looking at it graphically, although it's not necessary. Thank you.